Number 37, we continue once again looking for critical numbers, intervals of increasing, decreasing, relative mins and max, using the calculator to verify our results. We start off with a quick analysis of the function. We have a vertical asymptote at x equals -1. We have to remember that. That cannot be a critical number, but it does influence our analysis. So we have f prime of x is x squared minus 2x plus 1 over x plus 1. Let's find, that's f of x. To find the derivative, first derivative, we'll do a quotient rule, low. D high is 2x minus 2 minus high x squared minus 2x plus 1 d low, which is just 1 all over low squared. Now we still need to multiply out the numerator. We're going to get 2x squared minus 2x minus 2x plus 2x. Fortunately, that's going to go away, and we're going to end up with minus 2x. No, it's not. It's 2x squared minus 2x plus 2x, yes, minus 2, then minus x squared plus 2x and minus 1. Once again, all over x plus 1 squared. No need to multiply that out. And in our numerator, we end up with x squared. Then the 2x's cancel out, and we have another 2x later on. So it's plus 2x, then minus 2 minus 1 is going to give us a minus 3 over x plus 1 squared. A rational function is 0 when its numerator is 0. Let's see if that can be factored. And we'll have x plus 3x minus 1 over x plus 1 squared. And so we can see that will equal 0 when x is equal to -3 and x is equal to 1. X is equal to -1 is a vertical asymptote, so we're not going to worry about that, but it will go on to our sign chart. X is equal to -1. Then we have -3, and we have +1. So that breaks our number line up. We need test values for each interval. And we're going to go back to the derivative. And if we have a factored form for the derivative, that's going to be easiest. Note that the denominator will always be positive. We only need to worry about the numerator. Plugging in -4, we get negative, negative, so that will be positive. Plugging in -2, we get positive, negative, so that's negative. Plugging in 0, we get positive, negative, and so that's negative. Plugging in 2, we get positive, positive, and so that is positive. Let's do our analysis. The function increases from -infinity to -3, and from 1 to infinity. It decreases from -3 to -1, and then again from -1 to positive 1. We go up and then down, down, and then up, and it appears we have a relative max at x equals -3. We'll come back and get the y-coordinate, and a relative min when x is positive 1. We'll come back and get the y-coordinate. Plugging into the original function, -3. So we would say f of -3, that's going to be 9 plus 6 is 15 plus 1 is 16 over -2, which would be -8. So the maximum was at -3, -8. The minimum we plug in 1. So we're looking for f of 1. Plugging that in, we get 1 minus 2 is -1 plus 1 is 0 over 2. So that's going to be at 0. Alright, so let's see how we did. We'll bring in the graphing calculator, and we'll need to put the numerator in parentheses now, so you want to be careful about that. X squared minus 2x plus 1, all wrapped in parentheses, and the denominator in parentheses, x plus 1, and we'll zoom standard, and we do get something very crazy here, but I think we're in good shape. So I'm going to take a picture. We'll place that on our workspace, and we can see, first of all, we do have our vertical asymptote at -1. We have our maximum value, which appears to be right there at -3 and -8. We have our minimum value, which was at 1 and 0. The function was increasing from infinity to -3. Then it decreases from -3 to -1. It decreases again from -1 to +1, and increases from 1 to infinity. So we had that all right there, and we will go on to the next problem in the next video.